Welcome to Management Science 291, Statistics for Business and Economics, your second course in stats. So today we're going to start our video lectures. I'm going to talk kind of quickly through these because there's nothing worse, I think, than listening to a slow video where it seems like you're just waiting and hanging on every word. You can pause me if you need to write something down. So I'm going to move a little bit quicker than I normally do, and I'm hoping that it's going to be a better experience on your end. So we're going to break most of these lectures up into parts, so don't be surprised when a video ends before your set of lecture notes. All right, so this first set that we're going to go over is the intro to the course, review of basics, graphical displays, and this is chapters 1, 2, and 3. All right, so statistics is the study of the collection, organization, analysis, interpretation, and presentation of data. And Hal Varian, chief economist at Google, says, "I keep saying that the sexy job in the next 10 years will be statisticians, and I'm not kidding." If you do a search for open positions at Facebook in data and analytics, you will see that there are 164 positions open as of the time that I did this Google search. And it has scrolling banners. So I stopped it on this guy, Rick M. He says, "If there's no set solution for your problem, you hack it and solve it yourself." I love that because that's exactly the way I want you to feel when you get out of this course. All right, best 11 jobs in America. Data scientists on this list is number 1, ranking $110,000 a year, ranking number 1. So just in case you were ever interested, it is a very hot career path to get into. And in this day and age, you're expected to know a little bit about data science anyway. All right, so this course has a goal to develop a practical, real-world approach to using statistics. We're going to understand the data, use the appropriate statistical tools, and communicate the insights. So it's going to be a little bit different than your previous statistics course in that we're going to be heavy emphasis on the applied, understanding what the data means and what you can do with it. I've had on student evaluations, I love it, students say things like, "This course made me think." And I know that's a really good skill. You know, I think they were admitting that sometimes they have courses where they can just memorize things and put it back down on a test. But with your case studies and projects, you are going to have to do some thinking. All right, so the first step is developing a toolkit. You're going to learn R, which is a statistical software programming language. It's free and it is a hot skill right now. Many careers in business will use it. So it's going to be useful to many of you. We're going to review basics of stats. So lots of this first part of the semester are going to be a review of what you learned last semester. And you're going to learn a little bit more about Excel on top of what you already learned in 290. All right, number 2 is to test the ideas. We're going to do confidence intervals, hypothesis tests, something called ANOVA, which is analysis of variance, and regression, and advanced topics in regression. And then advanced regression and forecasting. So that's this course in a nutshell. All right, so why are we teaching you R? Well, Excel is very good at a lot of things. It's good at quickly crunching data sets, making quick calculations, data manipulation and summary like pivot tables, and it's getting much better at graphical displays. But it breaks down for large data sets. For instance, Excel has the maximum number of rows at 2 to the 20th power, which is a little over 1 million, and R maxes out at 2 to the 31st power minus 1. So a very large number. So much bigger data sets than Excel can handle. And believe me, in this day and age, 1 million rows will go by very quickly. So Excel breaks down for statistical analysis. It's meant to, house smallish to medium-sized data sets, some semi-large, do some manipulation, do some quick things. But it's not created for statistical analysis, so it breaks down at anything past like a simple t-test. It breaks down in the ability to create unique, highly customizable graphical displays. The advantages of R, just a couple to name, are its more powerful data manipulation capabilities, easier automation, faster computation, supports much larger data sets, easier to detect and fix errors. It's free, It's open source, meaning many people contribute packages to it to improve its functionality. It's got very advanced statistical capabilities. It can create unique, highly customizable graphical displays. You'll be creating one for me for your first project. And it runs on many platforms. So R has many, many advantages. Big companies use R. So let's take a look. Okay, so a list of big companies using R. Google uses R in many ways. They use R to make online advertising more effective. They also use it for economic forecasting and big data statistical modeling. Facebook uses it for exploratory data analysis, experimental analysis, big data visualization, human resources, and user behavior analysis related to status updates and profile pictures. A Facebook data scientist, Carl Duke, created an analysis on the formation of love based on Facebook relationship status updates. And what they found is that as the relationship is formed, the number of timeline posts goes down. However, the amount of positive emotions in the posts rise. Twitter uses it for data visualization, semantic clustering. Airbnb uses it. They've got an internal package called Airbnb. They use R to scale data science. They use R to predict rebooking rates using past guest ratings and to automate guest or host matching. Microsoft uses it. A software company that has their own statistical software actually uses R. IBM has their own statistical software. They use R. John Deere, they manufacture agricultural, construction, and forestry machinery, diesel engines, drivetrains. And in 2016, it was listed as the 97th in Fortune 500 America's ranking. It was ranked 364th in the global ranking in 2016. They also provide financial services and other related activities. They use R for short and long-term forecasting, forecasting crop yields, data coordination, and optimizing the build order on the production line. ANZ Bank, Zillow, and Trulia. You'll be using a large data set for home prices, just like Zillow is trying to do, forecast home prices. You can read through the rest of this article as you have time. But I wanted to just show you at least one article talking about how many big companies use R. Okay, so now we're going to get into the Chapter 1 background information. Most of this should be a review for you guys. So, descriptive statistics is collecting, organizing, and presenting data. Inferential statistics is when you use that to draw conclusions about the population. And usually you've drawn a sample from that population, and then you infer from that sample about the population. A parameter is a number that's used to describe a population, and a statistic is a number that's used to describe a sample. Notice the alliteration: parameter, population, statistic, sample. And then we use those statistics to estimate our population parameters. All right, time series data are when you measure variables at regular intervals over time. So it could be hourly, daily, weekly, monthly, quarterly, annual, etc., as long as you're measuring at regular time points. When several variables are all measured at the same time point or time frame, the data is called cross-sectional data. Example, data on sales revenue, number of customers, and expenses for last month at each of Starbucks, more than 20,000 locations, would be what? So is that time series or cross-sectional? All right, so this one is not measured at regular time intervals. It's just in one time frame, that is last month, so that's going to be cross-sectional. Businesses rely on data for planning and to improve efficiency and quality. Most modern businesses collect information on virtually every transaction performed by the organization, including every item bought or sold. And then these data are recorded and stored electronically in vast digital repositories called data warehouses. In the past few decades, these data warehouses have grown enormously in size, but with the use of powerful computers, the information contained in them is accessible and used to help make decisions. So the huge capacity of these warehouses has given rise to the term big data to describe data sets so large that traditional methods of storage and analysis are inadequate. Dealing with big data has pros and cons. For example, sometimes a relationship appears that is not real. When you have millions and billions of observations on millions of variables, you're looking at so many comparisons that sometimes you're going to see a relationship that just shows up by chance alone. So some insights from MasterCard's big data is that every city has its DNA for spending distribution. Here you can see in this simple stacked bar chart that New York and Chicago and Los Angeles are a little bit more similar in that their shopping is about 30%, but Miami and Las Vegas are different in that their travel is around 50%. So they use big data to leverage, how people are using their credit cards. All right, so the data sets we'll be working with are somewhat large, but I still wouldn't call them big data. Big data is when you can't even imagine how large it is. Okay, you need a data warehouse to house it rather than just a computer or hard drive. All right, so the variables we are trying to measure are found in the columns of a data set and are the characteristics of the units that we take measurements on, which are the rows. So notice here in this little data set, we've got a transaction number. It's called an order number. All right, that's going to be a special kind of variable we'll learn about in a minute called an identifier variable. And then we've got the name of the customer, the state, the price for the product, an area code, album download, whether it was a gift or not, the stock ID, and the artist. All right, and these are different kinds of variables. We're going to talk about the different kinds of variables. So we've got quantitative or qualitative variables. Quantitative variables are numerical. They take on numerical values, and they actually work like a number. Like, it makes sense to do computations on them, like take an average or a standard deviation. And then qualitative data are when you're putting things into categories. So they don't have a meaningful numerical value. Sometimes they show up as numbers, but they're not meant to be averaged or anything like that. And these are otherwise known as categorical variables. Quantitative variables must have units. The units indicate how each value has been measured, the corresponding scale of measurement, how much of something we have, how far apart two values are. Quantitative variables are sometimes divided even further into two different types of quantitative variables, discrete and continuous. Discrete is when there are jumps between the possible values, and continuous variables is when, for any two values, you can always find another value in between them. For example, if you're weighing subjects in pounds for a weight loss program, what kind of variable is weight of a person? Well, it's quantitative, clearly, right? Your data set, your Excel spreadsheet that you collect your data in is going to have a list of numbers under weight of a person. And theoretically, if your measuring instrument would allow, you could go out to infinite decimal places when you're weighing somebody. So technically, this is a quantitative and continuous random variable. All right, another example. In weightlifting, if weight can only be added to the bar in 5-pound increments, and you're recording personal records for the deadlift for members of a gym, what type of variable is weight lifted? Well, again, obviously it's quantitative. Your data set, your Excel spreadsheet's going to have numbers in that column, and it's going to make sense to average them, get an average personal record for deadlift, things like that. So quantitative. And this time it's going to be discrete because weight can only be added in 5-pound increments. You can find two numbers such that there is not another number in between them. All right, so when we talk about categorical variables, these arise from descriptive responses to questions like, what kind of advertising do you use? It might only have two possible values, like yes or no, and it might be actually represented with a number like a zip code. But again, we wouldn't treat that as a quantitative variable because it doesn't make sense to average zip codes. So for instance, do you invest in the stock market? The answers would be yes or no. That's categorical. What type of advertising do you use? Internet, newspaper, radio? Categorical. Or rate your satisfaction with this product. We call this kind of a Likert scale. Very negative, negative, neutral, positive, very positive. All right, so again, sometimes it is helpful to classify further categorical variables into even more refined categories. So we've got nominal variables, which is when your names of your categories are just the name of a category. It doesn't make sense to have some kind of an order. And then when it does make sense to order the categories, there's some kind of underlying scale that you have more of something as you go through categories. We call those ordinal categorical random variables. For examples, employees could be ranked according to the length of time employed, like less than 5 years, between 5 and 10, or greater than 10 years. So let's try 2 examples. If I asked you your class, freshman, sophomore, junior, senior, or graduate, what kind of variable is that? Well, clearly it's categorical because you're putting things into categories. And your Excel spreadsheet would have a word in that column, so definitely that's categorical. So now we just need to decide whether it's just the name of a category or whether there's some natural ordering. And I think you all can clearly see that there's some natural ordering here. You have more of something as you go through these categories, which is credit hours actually. So ordinal. And how about store type, grocery, clothing, hardware, art, or other? This is just the name of a category. There is no natural ordering to them, so categorical and nominal. All right, I want to point out that sometimes your variables could be treated as quantitative or they can be treated as categorical. So it depends on why you're collecting the data. For example, age is quantitative. If I just asked your age, it's a quantitative variable. You can take the average age, you can compute those numbers. But sometimes we might want to find an age range and just say, you know, child, adult, senior, or whatever. When you treat age like that and you put it into categories, then we treat it like a categorical variable. And last but not least, what I promised at the beginning of introducing these variables is the identifier variable. This is a unique identifier assigned to each individual or item in a group. Identifier variables don't have units. They're a special kind of categorical variable, and they're useful in combining data from different sources to avoid duplication. And they are not to be analyzed. For example, your Social Security number is an identifier variable. It's a unique number attached to each one of us. But it's not treated like a quantitative variable. We don't take average Social Security numbers. It's just an identifier variable. Your student ID number, tracking numbers, transaction numbers, etc.